Here's the disassembled engine. Notice the bearing block. It has a ball bearing Loctited in each end. There are 3 tapped holes on the face, and the outer diameter serves as a bearing for the cylinder frame assembly. I'll put that on now. The cylinder frame clutch retains the cylinder frame to the bearing block by clamping through this Teflon pad. The clutch is held to the face of the bearing block by 3 screws. The clutch screws are tightened. The Teflon surface gives a firm, smooth movement for adjustment of the cylinder frame angle. The crankshaft is installed. Low friction is essential for a small Stirling engine of this type. The crankshaft spins freely. Installing the flywheel at this time will keep the crankshaft in place. A tapered bushing in the flywheel clamps it firmly to the shaft. The piston and rod assembly is installed. Care is taken not to dirty, even with finger oil, the sliding surface of the graphite piston. The end cap is installed on the connecting rod. A fiddly job under any circumstances, but difficult with the camera in the way and without moving the engine. A lot of fumbling and dropping of the number 0 screws has been edited out. Next, the displacer is installed through the hot side opening. The rod is slipped through the displacer rod gland. First, a locking nut is threaded onto the displacer rod. Then the forked pivot for the displacer connecting rod. The locking nut allows for the adjustment and fixing of the pivot position. The displacer connecting rod is slipped onto its crank pin. The other end is then slipped into the forked pivot on the displacer rod. This tiny purpose-made shoulder screw serves as the pivot pin. It's installed now. A washer and screw retain the displacer connecting rod on its crank pin. Now it's time to install the hot cap. It's sealed by a silicone O-ring at the junction with the cooler. The O-ring is still stuck to the hot cap from the previous assembly. That's convenient, as I failed to provide a groove for the O-ring to seat in. The clamping ring is held by 6 small and fiddly screws. Again, the process has been condensed to save you watching a lot of fumbling and dropping. The screws are iteratively tightened in a number of steps to get an even and tight seal. The flexible PVC connecting tube between the cooler and power cylinder is installed. It's had an extension spring slipped over it to keep it from collapsing. Finally, the phase adjustment lever is screwed into place. I'll go back and fine-tune the tightness of a few screws that may have been overlooked, and then the engine will be ready to run again. While that warms up, I want to say a word about how the phase angle change works. Built into the crank is a 41-degree lead for the crank pin of the displacer ahead of the piston crank pin. That 41 added to this angle is the total phase angle for the engine. So in other words, 41 here, 40 here makes 81 at that setting. Of course, I can change it throughout the range.